Hi, my name is Ondina Menjivar from 11.1 and today's topic is limiting reactant. Today we are going to explain some equations and also we're going to try to resolve them step by step. So the problem says, in the following equations, determine which reactant is a limiting reactant and the excess. The amounts are given below of each reactant. Show evidence for your answers. And this is our first equation. The first thing that we need to make is to check if our equation is balanced. Here we have 1 potassium in my reactant and 1 potassium in my product. Here I have 4 oxygens in my reactant and 4 in my product. And here I have 2 hydrogens and also in my product I have 2 hydrogens. So yes, my equation is balanced. The first thing that we are going to make is to take the molar mass of all. This is given, but this we are going to find it. So first, the step one is find the molar mass. So I have this one first, that is potassium, oxygen, and hydrogen. I will find this one. This is the molar mass of each one. So I will write potassium, oxygen, and hydrogen. I don't have any number of subscript, so I deduct that is 1 each one. So it's 1 of potassium, and potassium is 39.098. Then I have oxygen, that is 1 also, and is 15.991. We have hydrogen, that is also 1, and is 1.0079. These we are going to add them. So it's potassium 39.098 plus 1 and oxygen, that is 15.999. In this case I won't round it. And then finally is 1.00789. This will give me 56.1049. So see, 56.1049. So the next one that I will find is for hydrogen, nitrogen, and oxygen. That is the molar mass so I have hydrogen, nitrogen, and oxygen. I have 1 as subscript, and hydrogen is 1.0079. Of nitrogen, I have 1 and is 14.006. And in oxygen is different because I have 3 as a subscript. So I put a 3, and oxygen is 15.999. We're going to make the same. We are going to add them. And 3, 15. And gives me 63.019. 63 0.0109. The next one that I will find is this one. That is a molar mass of potassium, nitrogen, and oxygen. I have potassium, nitrogen. Of potassium, I have one subscript, and the molar mass of potassium is 39.098. Of nitrogen, I have 1 and is 14.006. And of oxygen, I have 3 subscript, and oxygen is 15.999. So this value, I will add it. And gives me 101.101. So I already have my values, the molar mass of each one. So the next step is to know which is the limiting reactant and the reactant that is in excess. So my step 2 is find my limiting reactant and also the excess reactant. For this, first I will divide like my reactant 1, that will be this one, and my reactant 2, that will be this one. So first, I will put the grams given. That will be 40 grams of Co. Okay? Then I will put in 1 mole, I will put my molar mass. That will be this one. In 1 mole of Co, are 56.1049 grams of Co. So, what's next one? I want to find the moles of this one. So I will place 1 mole of potassium, nitrogen, and oxygen under the 1 mole of Co. Then we're going to place here the molar mass of the one that we want to take, like the one that we are finding. So is 101.101 grams mole of potassium, nitrogen, oxygen. And this one over 1 mole of potassium, nitrogen, and oxygen. So, the first step that we are going to make is to cancel. To cancel for this, I will cancel this with this. I will cancel mole of coke with mole of coke, 1 mole, this, and I'm going to cancel with this one. So the next step is to multiply all that is over here and dividing with all the values over here. So we make 40 times 1 and 1, that is the same, and 101.101 divided by 56.1049, and this will gives me 72.079, and this I will round it to 72.08, and I will copy this over here, that is grams mole of the one that we were finding. So this is the first reactant. Next we have the second reactant. Reactant number 2. So this says that it is 55 grams. 65 5 grams of hydrogen, nitrogen, and oxygen. So I will put that in 1 mole is 63.0109 grams of hydrogen, nitrogen, and oxygen. So this. Then I have to put the value that I'm finding. So it is 1 mole of this one that is unknown. Is this step is the same that we made with the first one. And here we are going to put the molar mass of the one that we are finding, that is 101 on 101 grams of over 1 mole then we have to multiply. No, first we're going to cancel this with this, this with this, and this with this. So we're going to multiply, and it's 65 times 101.101 divided by 63.0109. This gives me 104.2925. These we're going to round it and will be 104.29. of potassium, nitrogen, and oxygen. So here that we have the two reactants and the values of each one. This is the last one. So this one will be my limiting reactant. And this one is the value is the biggest one. So will be my excess. Excess reactant. So we already know this, but we are going to make it in a sentence. So we say that co is the limiting reactant. And hydrogen, nitrogen, and oxygen, 3. Is the excess excess reactant. And this one is already done, but is missing one. Now we are going to make it over here. That is easiest. It's the same process, only that is another equation. So we say that step 1 was to find the molar mass of each one. So, is this equation balanced? Yes, it's balanced. We have 2 of sodium. We have here 2 of sodium in my product. I have 2 oxygens and also 4 oxygens. That makes 6, and we have 4 oxygens over here and 1 over here. So we're going to find the molar mass of each one. The first one that we are going to take is of sodium, oxygen, and hydrogen. That is the molar mass of oxygen and hydrogen. So this will help me, and this is my coefficient, but not my subscript. So this I won't use it until then. So this won't affect all the equation. So I have 1 subscript of sodium, and here says that the molar mass of sodium is 22.989. I have 1 of oxygen, and oxygen is 15.999. Hydrogen, I have 1 as subscript, and I will write 1.0078. This I will add it, that is 1. This will gives me 39.9959. Then I will take the molar mass of the second one, and that is hydrogen, sulfur, and oxygen. This will help us. This is different because we have it as a subscript, so we're going to write 2, and hydrogen is 1.0079. Sulfur only have 1, so it's 32.064, and oxygen has 4, so oxygen is 1.0079. We're going to make the same. We are going to add them. These I will make it again. This gives me 98.0758. Then I will take the molar mass of the other one that is unknown, that is this one. I have 2 as subscript, and sodium have 22.989. Sulfur have 1, and sulfur is 32.064, and oxygen have 4 and has 15.999. So I will make the same. I will add them. This gives me 142.03, and this is so this was my step 1. Take the molar mass of each one. So my second step will be to divide into reactant 1 and reactant 2, right? So reactant 1. the equations tell me that I have 65 grams. So if I will write 65 grams of NaOH, and we're going to multiply times in 1 mole of NaO, we have this value. So it's 39.900 grams of and we're going to put here the one that we want to find. So will be 1 mole now under 1 mole so this I am going to multiply by my molar mass of the one that I am finding, that is I know. Over 1 mole so I am going to multiply all that is over here and divide it by all that is over here. Divided by here I change for 2 because you can see that I have 2 as coefficient. So in 2 moles of NaOH I have 1 mole of Na2 SO4. So multiplies by 2 and this will gives me 115 point remember that I write this one because I cancel this. I can cancel this. Okay. So I will make my second reactant. That is this one. Says that 42 grams of H2SO4 is in 1 mole SO4 over my molar mass that was 98.9
0.0758, and this is grams H2SO4. And here I will put the moles of the unknown, that is 1 mole of Na2SO4 over 1 mole of H2SO4. Here we are going to place a molar mass of my unknown, and is Na2SO4. This I'm going to multiply. First cancel. So it's 42 divided by 98.0758. This gives me 60.82, that rounded is 60.83. Grams of Na2SO4. So I have the two values of my reactant 1, reactant 2, and we can see that the difference is like very big, and this is the excess. Why? Because it's the biggest value. Excess reactant. And the last one is my limiting reactant. So I will formulate in a sentence, and will be 2 now 08 is the excess reactant, and H2 SO4 is the limiting reactant.
So that's all. Thanks for watching, and thank you.